Welcome to our discussion topic of the day. We are going to talk about nitrogen and its compound. So before we continue, please like, share and subscribe to our channel if you haven't, and let us start. Now we are going to discuss the topic using questions because that is the proper way of you understanding the concepts. So we are going to start with this. So here we have a flow chart. Okay, the first question and the second question. So as you can see in the first question, you have hydrogen. We said you're going to be guided by the flow or the direction of the arrow. So we can see we have our hydrogen coming this way, and we have number 1 there. So we have a substance here that is coming like this, and you can see we have ammonia here. Do we have anything else? Yes, we have nitric acid. So let us begin. Here we are dealing with the formation of ammonia, and we know for you to form ammonia, ammonium is formed by only 2 substances, which is what? Hydrogen and nitrogen. So before we even proceed, we can just write it here very fast. So it means that in number 1, this is where we have what? Our nitrogen. So nitrogen combines with hydrogen to form ammonia. Okay, now nitrogen is diatomic. Nitrogen gas is diatomic. That is why we're writing N2 there. Let us come here. So we can see the whole process leads to the final product that is being formed is nitric acid. So this means that we have like the Ostwald process that is going to occur here, because Ostwald process is the industrial production of what? Of our nitric acid. Now, what is required for nitric acid to be formed? One thing is we require the formation of nitrogen 2 oxide. Okay, so once nitrogen 2 oxide has been formed, it again further gets oxidized to form nitrogen 4 oxide, which gets hydrolyzed by water. This is addition of water to nitrogen 4 oxide for you to get what we call nitric acid. Okay, and also nitrous acid or nitric 5 acid. So let us proceed. Now the first thing that we can see here, we have hydrogen and nitrogen reacting to form our ammonia. Okay, now which or where do we get the hydrogen? What is the source of our hydrogen here, and what is the source of nitrogen? Yes, we say we get our hydrogen from cracking of long chain alkanes. Okay, or also you can talk about what? Electrolysis of brine. Okay, so we get it from cracking long chain alkanes, and we have also said from what? Electrolysis of what? Of brine. So those are the 2 sources of our what? Of our hydrogen. And what is the source of our nitrogen? So nitrogen is gotten, or we get it from what? Fractional distillation of liquefied air. We get it from fractional distillation of liquefied air. Okay, so we have our hydrogen and nitrogen reacting to form ammonia. So the reaction that we are going to, they react to form what? Ammonia. Now our ammonia, we have an arrow coming like this. So the ammonia goes this way, and we have a substance 2 that is coming on this side to go to our substance 3, which goes to 4, and then we also have 4 here, we have 5, we have 6, and we have 7. So let us proceed. We've said for us to form nitric 5 acid or nitric acid, it undergoes what? Which process? We said it's called what? Ostwald. It's an Ostwald process. And so here the question is testing if you know the formation, the industrial formation of nitric acid. You see, so if it's an Ostwald process, we said for you to form your nitric acid, you first start by formation of nitrogen 2 oxide. Okay, so how do we get this nitrogen 2 oxide? Wow, we come here to our ammonia. Okay, so we have ammonia there, and we have ammonia there. Okay, so ammonia is coming like this. So for us to form our nitrogen 2 oxide, yeah, what we're going to do is we are going to react our ammonia with oxygen gas. So in 2, we are going to say here we have our oxygen gas. So once you get your oxygen gas, what is going to happen? Now the reaction that is going to occur here is you're going to write your ammonia, you react it with oxygen, okay? Or oxidation. Simply this is oxidation of ammonia. Okay, so once you oxidize, it's normally catalytic oxidation of ammonia. So once you oxidize ammonia, you are going to get your nitrogen 2 oxide and water. Okay, we put the state symbols first. After putting our state symbols, we are going to balance by putting a 5 there. Okay, and and putting a 4 there. So we are going to balance it by putting another 6 there. Okay, so we have formed our nitrogen 2 oxide. So we are going to put nitrogen 2 oxide there. So after you have formed your nitrogen 2 oxide, we can see we have something that is being brought here from 4. The arrow, the direction of the arrow is coming like this, and you can see your nitrogen 2 oxide is also going like this. So it means that we have something here, and this thing we're going to say it is what? It is our oxygen gas again. Why? Because once nitrogen 2 oxide has been formed, yeah, it is going to react with our oxygen to form nitrogen 4 oxide gas. Symbols again. And balancing, in this case, we start by balancing the number of oxygen atoms. So we are going to balance by putting a 2 there and a 2 there, because here we had 2, here we didn't have any. So that's why I kept a 2 first on this other side here. Now we have formed our nitrogen 4 oxide. So number 5, we have what? Nitrogen 4 oxide gas. So remember the whole Ostwald process, and I have explained it in a video below. So you can check it out if you still haven't if you can't remember it properly. So during the formation of your nitrogen 4 oxide, your nitrogen 4 oxide is again going to do what? It is going to react with water. Okay, so nitrogen 4 oxide is going to undergo hydrolysis for you to form what? Nitric acid. And another thing that is also going to occur is, so we can have, so this we have 2 arrows here. So nitrogen 4 oxide is going like this, yeah. Now we have here, we can say here we have what? Water, because we've said it is hydrolysis. And also what? We have the addition of more oxygen or air. So here we are going to say the reaction that is going to occur there is your nitrogen 4 oxide that was formed. It's going to react with water, a process that is referred to as what? Hydrolysis, to form nitrous acid and nitric acid. Nitrous acid is written as HNO2 and nitric acid is HNO3, nitric 5 acid. So we are going to balance by putting a 2 there, and we are through with this flowchart. So they were asking you to label the numbers. It was 1, 2, 3, 4, 5, like that. Okay, now another thing they asked was the use of, here was 1, the use of the substance in 1. So what is the use of nitrogen in Haber process in the manufacture of nitric acid? And a second use of our nitrogen gas is going to be in packaging oxidized foods such as coffee. And the last that we're going to talk about, it is not the last one, but the third one is freeze drying foods. So those are some of the use of nitrogen gas. Now that is it about this flowchart. Let us go to the second flowchart. Now here you have PQ. You have a blank there. So it means P and Q is forming something, which again is taken down here. We are following the direction of the arrow to form our R. Okay, and as you can see in your R is going to be reacted with a substance S and a substance and air to form nitric acid. Again, the whole Ostwald process, like the industrial manufacture of nitric acid. And we know for you to form nitric acid, you have to start with what? You need to have nitrogen. We have said nitrogen is used in the Haber process, which is industrial manufacture of what? Ammonia. So we need to start with ammonia. Now for you to form ammonia, ammonia is a nitride of hydrogen, or it is a hydride of nitrogen, meaning it is made up of two components, nitrogen and hydrogen. So our P and our Q can be hydrogen or nitrogen. You can interchange it. It doesn't matter. So let us write our P. I hope now you're through with this side. Let us write our P here. So our P here is going to be what? Nitrogen, and our Q here is going to be what? Hydrogen. Let us write here our ammonia. Okay. Now, our ammonia is going to do what? It is going to be oxidized. This is the process that is going to occur here, okay? For you to form your nitrogen 2 oxide. So, our R is going to be nitrogen what? 2 oxide. After you have formed your nitrogen 2 oxide, for you to form nitric acid, the nitrogen 2 oxide needs to be oxidized to form nitrogen 4 oxide. That is why you can see here air. Where you see air, it means we have what? Oxygen gas there. So here we're talking about what? Oxygen gas. So oxidation of your nitrogen 2 oxide to form what? To form nitrogen 4 oxide. This reaction, okay? And after you have formed your nitrogen 4 oxide, our substance S is going to be what? It's going to be automatically water, so that the water can hydrolyze the nitrogen 4 oxide that was formed. This whole process, we've said first nitrogen 2 oxide is going to be formed, which is this, and this is the reaction, okay? This is the chemical equation for the formation of your nitrogen 2 oxide. This is it. And after formation of nitrogen 2 oxide, we have air which has oxygen, meaning it's going to oxidize our nitrogen 2 oxide to form nitrogen 4 oxide, okay? After you have formed your nitrogen 4 oxide, it is going to be hydrolyzed, which is now this, that reaction, to form nitrous acid and nitric 5 acid. So that is why we've kept water here, and the reaction or the equation is this one. So that is how you do these questions under nitrogen and its compound. Okay, now how do you test for ammonia gas? How do you test it? Ammonia has a pungent smell. Another thing about ammonia, take a glass rod. You know what a glass rod looks like, and glass rod is going to have, you're going to wrap it up with a cotton wool. Remember, the cotton wool is soaked with what? Hydrochloric acid. Once you put it on the test tube which has ammonium solution in it, or this solution that we do not know what it is and we want to check if it is ammonia, it's going to form dense white fumes. So that is how you test for ammonia. You say you dip a glass rod in concentrated hydrochloric acid and bring it to the mouth of a test tube which contains a solution of ammonia, and it is going to form dense white fumes, okay? Another thing that we need to know about ammonia is what? Ammonia, during the formation of ammonia, the ammonia gas that we form is normally what? Dried. Why do we dry it, and what do we use to dry? So the drying agents that we use during the formation of ammonia is calcium what? Calcium oxide, or something that we refer to as quick lime. Okay, so these are the drying agents of our ammonia. Up to there we fine? So quick lime or calcium oxide is used in drying as a drying agent for ammonia. Why do we use this and not other drying agents? So other drying agents include calcium chloride, okay? And we can also talk about sulfuric acid. Okay, so sulfuric acid is a drying agent. Calcium chloride is also a drying agent, but you cannot use both calcium chloride and sulfuric acid to dry your ammonia gas, which you have said it's normally dried during, like when you're doing the lab preparation, yeah? So we do not use both of them, because when you use sulfuric acid, we are going to form ammonium sulfate, and when you use calcium chloride, you're going to form tetramine calcium chloride. So that is why calcium oxide or quicklime is the best drying agent for ammonia. Another thing we need to know ammonia is the method of collection. Ammonia is collected using downward delivery or upward displacement. So we can talk about downward delivery, okay, or we have said what? Upward displacement. method. Is it about ammonia preparation, okay, as well as what, nitric acid formation through Ostwald, a process that is referred to as Ostwald process.